Wall is perhaps the most basic Revit elements you will use when working with Revit. And most likely it'll be the first Revit elements that you will place on your project. So when it comes to Revit model elements, it makes sense for us to start here. Let's get started. To get to the wall command, you will go to Architecture tab, then under Build panel, you will click on the wall icon. Now the wall icon is split. It has the top half and it has the bottom half. If you click on the bottom half, it's going to give you a drop-down menu that shows you a few other options. For the purpose of this course, we will only focus on wall architectural. And by default, if you click on the top half, it'll take us to wall architectural. Now the shortcut for this command is WA. Now as always, when you execute a new command, you always check the ribbon, option bar, properties palette, and status bar. On the far right of the ribbon, you see a draw panel. Under draw panels, you see various shapes that you can use to sketch your walls. In this course, we will only focus on line and pick lines. For now, I will use line. On the option bar, we will come back and revisit the option bar later. On the status bar, it tells us to click to enter wall starting point. Then enter wall endpoint. We will discuss space flip orientation later. After I click on the second point, wall is created. And if I continue to click, more walls will be added. Now this continuation of walls occurs because the chain option is checked on the option bar. If the chain is unchecked, you will only allow to add one wall at a time instead of string of walls. With the chain checked, I can just keep clicking and the wall will be added. To break the chain, I will hit Escape 1 on my keyboard once only. By hitting Escape once, I break the chain, but I'm still in the wall command, so I can continue to add more walls. If I hit Escape twice, it'll take me completely out of the wall command. You can tell that you are out of a command by looking at the ribbon. It'll turn back to architecture from Modify Place Wall. Also, the plus sign on the pointer change back to just a regular pointer. Instead of hitting Escape twice, you can also click on Modify to get out from a command. Now I'm going to get rid of all these walls. To do that, I'm going to hover over one of the wall, and it doesn't matter which one you hover over. Then right click and it's going to give me a pull down menu. I will select all instances, and I will select visible in view. By doing that, all walls instances that can be seen in this view will get selected. Then I can just simply hit delete on my keyboard to get rid of it. Now let's go back to the wall command, and this time we're going to talk about height. Under draw panels, you can see various shapes that you can use to create your walls. Even though for this course, we're only going to focus on line and pick lines. I want to encourage you to explore the rest of the options on your own. Now to control the height, I want to talk about reference planes for just a sec. On the previous video, I discussed reference planes in regards to building levels. If you haven't seen it, click on the link on the top right corner to get to that video. Now that the command is executed, let's have a look at Properties palette. Under Constraints in Property palette, Base Constraints refers to the bottom of the wall. And level 1 next to it is telling us that the bottom of the wall is going to attach to level 1. To make sure that you know what I'm talking about, level 1 that I'm referring to is building levels that can be seen on elevations. These are considered datum elements. I discussed Revit elements on a previous video. Click on the link on the top right corner of your screen to get to that video. Now that that is out of the way, let's get back to the floor plan. Based on what we see on the Properties palette, base of the wall that we are about to create will start at level 1. And if you want the base of the wall to be higher or lower than level 1, then positive or negative value need to be assigned to base offset. Right now it's set to 0, indicating that the base of the wall will be right on level 1. Now if I want the base of the wall to start at a foot above level 1, I will have to enter a positive 1 foot under base offset. In reverse, if I want the base of the wall to start a foot below level 1, I will need to enter a negative 1 foot under base offset. Now with that knowledge, we have established a starting point of the wall height. Now let's take a look at what controls the height of the wall. We're going to execute a wall command again. And now we're going to take a look at option bar. We will only focus on the second and the third options for now. The second option by default is unconnected, and the third option by default is 20 feet. We're just going to take it as is and place the wall. And once again, I will use line to sketch the wall. Then I will hit escape once to break the chain. And the next wall that I'm going to place, I'm going to set the height to 15 feet. Then place the next wall right next to the first wall. And hit escape once. The third wall, I'm going to make some change to the second option. Instead of unconnected, if I select level 1, the height of this wall or the top of the wall will be connected to level 1. But that makes no sense because the base of the wall is connected to level 1, and if the height of the wall is also connected to level 1, the height of the wall will be 0 feet and 0 inches. So I'm going to select level 2. Escape. And for the last wall, for the height, I'm going to have it connect to level 3. This time I'm going to hit escape twice to get out from the wall command. Since it is not possible for us to see the height of the wall in plan view, we're going to switch to south elevation. The first wall on the left is wall number 1. When we place this wall, we have height set to unconnected at 20 feet. To confirm this, on the property palette, 20 feet, unconnected. Next is wall number 2. It was set to 15 feet and unconnected. Next is wall number 3. When we placed this wall in floor plan, we had the top of the wall attached or connected with level 2. And since level 2 is 10 feet above level 1, wall number 3 is 10 feet in height. Finally, wall number 4. When we placed this wall again in plan view, we had the height of this wall or the top of this wall attached to level 3. And since level 3 is 15 feet above level 1, which is where the base of the wall is attached to, the height of this wall is 15 feet. Let's shift our focus to wall number 3. Since the top of wall number 3 is attached to level 2, if I change the height of level 2 to 9 feet above level 1, the total height of wall number 3 will change to 9 feet as well. Again, since the base constraint of wall number 3 is set to level 1 and the top constraint of wall number 3 is set to level 2. The top and the base of the wall will always follow the reference level. Same thing with wall number 4. With wall number 4, we have top and base attached to a level. So if I change level 3 from 15 feet to 20 feet, the total height of wall number 4 will change to 20 feet as well. Once again, because the top constraint is set to level 3 and the base constraint is set to level 1. With all the changes that we made to level 1 and level 2, you probably noticed that there were no change to wall number 1 and wall number 2. That is because the top constraint for wall number 1 and wall number 2 were set to unconnected. So the height of these two walls were unaffected by the changes that we made to level 1 and level 2. As you can see, wall number 3 has the unconnected height of 15 feet and wall number 1 has the unconnected height of 20 feet. With wall number 1 selected, let's change the unconnected height from 20 feet to 17 feet and see how it affects this wall. As you can see, the height of the walls changes from 20 feet to 17 feet, as specified in the property palette. Next, let's take a look at what offset does for us. With wall number 1 still selected, if I change the base offset to positive 1 foot, you will see that the base of the wall is pulled away from level 1 while the total height of the wall maintained at 17 feet 0 inches. Let's try something a little bit different with wall number 2. With wall number 2, I'm going to change the base offset to negative 2 feet. By doing that, the base of wall number 2 will drop below level 1 by 2 feet while the total height of wall number 2 still maintained at 15 feet 0 inches. Now let's take a look at wall number 3 and wall number 4. With these two walls, we have both top and bottoms attached to a level. In this case, if we change either the base or the top offset, the total height of the wall will either be added or subtracted based on the positive or the negative value that we assign to the offset. For example, with wall number 3, if I offset the base to positive 2 feet, you will see that the base is pulled away from level 1 and the total height is reduced by 2 feet. Therefore, the total height of this wall is now 7 feet instead of 9 feet. Let's do the opposite to wall number 4. With wall number 4, I'm going to change the base offset to negative 2 feet. By doing so, you will see that the base of wall number 4 will drop 2 feet below level 1. And while the top is still attached to level 3, the total height of wall number 4 is now 20 feet plus 2 feet, which is 22 feet 0 inches. With regards to the top offset, same effect happens when we change the offset. With wall number 4 still selected, I'm going to change the top offset to positive 4 feet. When I confirm the changes, top of the wall will move toward the positive direction, which is above level 3 by 4 feet, and therefore make the total height of this wall 26 feet 0 inches. Hopefully with these examples, you now understand how base constraint, top constraint, and offset affects the height of the wall. Obviously, there are more that I need to cover in regards to wall, but I'm gonna stop this video right here and make a separate video for the remaining. Thank you for watching and see you again soon.